Hello friends, my name is Heisal Jason. So I am from NTTF Trichy. I am studying on Diploma Mechatronics Engineering and Smart Factory. I am here to present best shop talk of demand from our center. It's Servo Motor. So just jump into our topic. So today days toys and protection they are mainly using servo motors or mini projects. So the person using diploma or engineering they will know about servo motor. So the normal peoples in like a child or some other peoples who is working part time or some trains they don't know about servo motors. So how it is servo motors working or how the motor is correctly turning in 90 and 180 degrees. So we can just check into our directly jump into the topic. So first of all, I will start with the normal classic definition of servo motor. It's like a normal motor. It's like a rotation or linear actuation. Uh, which is having a constant degree or angular control or speed control, linear motion, etc. So it was invented by a Jean Joseph Leon Farquhar. So he's a person who is working in a factory. He's like a normal super senior supervisor like that positions. So he was mainly finding difficulty problem or stopping in conveyor belt. Means it don't have angular stop. DC motors are using, so it will be rotating continuously. There will be no stop. Sensors are using, but it's not that much accurate. So he invented means a feedback system or sensor that can say the motor is in which level or which angle. So he added that and invented servo motor. So first of all, I will go with types of servo motor. There are several types: DC, AC. That two are the common types. Means normal people know AC current, DC current that works. So there will be two types of motor. Apart from that, water motors are there. So there will be position and rotation. Means these motors are used for rotating 360 like a stepper motor, and it can be used for accurate angle. I mean, normal. It's like more accurate than normal DC servo motors, etc. Then continuous rotation. So in servo motors, normal servo motor, it will be rotating 0 to 180 degree. Continuous rotation means it will be having a high torque with 360-degree accuracy. Then next will be coming as linear servo motors. So linear servo motor means a motor or servo motor which will rotate circular. So linear means it will go in a straight line or transversal lines. So I'll say my servo motor is coming under DC servo motor. In that DC servo motor, there are some types. So it's like its definition of motors or types of motors. There will be permanent magnet or serious wound, shunt wound, compound wound. Like that, in that motors, it is coming under permanent magnet or permanent magnet PMDC servo motor. So we are using a permanent magnet servo motors. Or in DC servo motor, it's classified as which type of motor is used in that servo motor. So in that permanent magnet, our servo motor SG90. My servo motor is I am take it SG90. In that SG90 permanent magnet motor is used. So here there's a transparent construction. You can see the motor will be blue color with some gears. So you can see how it is rotating and it will be maximum rotating 0 to 180. Here you can see two drive gears. So there'll be nearly 4 to 5 gears in that. So it will be using for converting speed into torque. So gears are mainly used for converting. If speed is decreasing, the torque will be increasing. Or speed is increasing, the torque will be decreasing. So gears are used for shift up or shift down, and also for equal speed. It's like a protection of motor or etc. Then potentiometer is used. I said there will be every sensors. So here the sensor is potentiometer. The change in resistance only the feedback is given to control. So integrated circuit. Here only the major roles have been played. So in servo motor we should give a pulse shape. So who study in diploma or engineering, they know how servo motors give means the signal which we are giving to servo motor will be in signal or square shape pulse. Then it is converted into voltage. So pulse to voltage converter on AC is used. So pulse means on, off, on, off. That is converted into voltage. Then it is given to comparator. So comparator means it's a voltage comparing, means input voltage and what is the feedback voltage. So if it is high or more, less or more, then it will tell the motor according to that. Then you can see a motor, as I say, it's a permanent motor and a servo motor case. Normally it will be plastic and transparent, means we can see that both sides of the motor. Then what is the difference between normal motor and the servo motor? So the only main difference is that it is having one feedback system using potentiometer. So it can stop the motor at which angle it needs. If, for example, it's having a 47K potentiometer, at 0K it will be in 0. and 0 degrees, and it's 47K half, it will be nearly for 20, 23, 23.5, yeah, 33.5K, it will be 90, and at full of 47K, it will be at 180. So the resistance change. So when the resistance has changed, the voltage level also will be changed. So like this, the circuit can understand the motor is in this level. Then they are using the motor is also lightweight, means we don't need torque for high torque for the motor, because we are using gears and it just need only high speed. So gears will be changing the speed into torques. So and then how a servo motor is working. So as I say earlier, the servo motor will be should feed it with this pulse signals. So that pulse signals will be changed into voltage levels, which will be compared later. So here you can see some pulses. So with 1 mil, it will be out of 10. Means if a pulse width or a pulse time on and off together, it will be 10 milliseconds together. In that, 1 milliseconds will be on, and the rest of the 9 milliseconds will be off. That means the motor is in 0 degree. Sorry. So laterly, if a pulse with modulation or the pulse is 10 milliseconds, as well as 1.5 milliseconds on, and rest of the 8.5 milliseconds are off, it will be 90 degree. Then next max pulse means maximum 180 degree, maximum rotation of servo motor. So here, if a 10 milliseconds pulse, 2 milliseconds will be on, and the rest of the 8 milliseconds is off, then it is considered as 180 degree. So it should be turned 180 degree. The voltage will be like circuit, or the IC can understand at which point or it should be stopped. Here you can see a amplifier circuit with a voltage converter. Means the pulse we are giving to servo motor will be converted to voltage level. It will be near between what means VCC and ground we are giving now. So the voltage will be between VCC and ground. The voltage means if you are giving 5 volt or 3.3 volt load you are connecting. So 0 to 3.3 volt, the voltage will be varying. Then it will be fed into comparator. The comparator will be comparing the feedback signal as well as the amplifier, means as well as the input signal, which is getted after the AC is converted. So if that difference is there, it will try to equalize it. Means if the input signal, for example, the input signal is more than the feedback signal, then it will be turning the motor to positive sides or negative, positive or negative, and trying to match it. Then you can see the gearbox, means from the position sensor. Here position sensor is the potentiometer or potential change in resistance only they are sensing and giving us voltage. Then working of servo motor. Here you can see some gears. First of all, I start with DC motor. So DC motor, there will be a magnet and it's rotating due to magnetic field. Change in magnetic field, it is rotating. So you can see here control circuit H bridge. So that means it will be normally it will be like optical optocoupler or something. So when a small voltage is given, it will convert into, it will like a transistor. It will open the high voltage gate and make the motors on. So then other one is that the potentiometer wires also fed into the circuit. So there is also comparator which will be calculating everything, pulse and as well as voltage levels, etc. Then the motor is attached with gearbox. So here you can see the speed coming from the motor. It will be like for example, 1000 RPM. If I am saying 1000 RPM, so it will be converted into 60 RPM due to reduction gears. When you are reducing the speed, as well, torque will be increasing parallelly. So if the torques are increasing, you can lift more weight from the using that motor. So it is also another advantage of gears. Then you can see potentiometer is connected as well as then downside. So how means the motor is turning, gear is also turning. Potentiometer also will turn. So it will try to match the angle or degree which is we are feeding into them. So here I mentioned some of the what is the maximum potentiometer range. So it's between two. What is the maximum torque? Sorry, what is the maximum torque that can be lifted by ST90? So it's between 2.5 kg, 1.5 kg, and 2.5 kg. So you can between that you can give the weight for torque or that much power it's having. And then what all things we required. So if we are going microcontrollers or embedded system, we are using a microcontroller. Then we are using two types of program. Either we are using a library file, means it will be stored in cloud. So we can use rotate to 90 degree. It will rotate the 90 degree. Otherwise, we can write a program like we want to generate a pulse. So on, off, like that, we want to write the program. Like if I am saying more technically, in embedded C, we want to write a digital write the number pin or signal pin, comma high. Then we have to give a millisecond, 1.5 milliseconds delay. Then again, we have to write low, then 10 milliseconds, 1.5, then 8.5 milliseconds. So it will turn into 90-degree. Otherwise, you can use a pulse width modulation circuit, which is like DAV circuits or etc. for controlling the potentiometer. So here I mentioned some pulses are used. So 1 millisecond means it will be 0 and rest of the 9 milliseconds should be off. So it will be marking itself or taking itself to 0. Then 1.5 it should be taking into 90 and 2 milliseconds it will be taking into 180 maximum. So because there is a potentiometer, if you are checking a normal potentiometer 270 degrees. So if a servo motor, if you are using, it's more easy to use in 180 degree or more accurate. If you are using more, or you can, if you want to rotate it in 360 degree, you can remove the potentiometer, so it will be searching for a feedback. But until that, you can control its angle. Then here some mentions of applications of servo motors. So normally we are using it for why we are using it for. It's cost effective or a high torque. Cost effective means at a less price itself we can get a high precision and all. Then high speed, or you can because of gears you can say, as I say, if the motor is rotating in 1000 RPMs, you can reduce that 500 RPMs. So torque is becoming double. If you are reducing again, it will become again double, or it's into for power 4, etc. So quick response. So if signals are reaching at a instance 10 milliseconds, a pulse width only is secure. So at that speed of instance, it will react. Then compatible size. So as you see, the servo motor S90, it will be like a centimeter size or 2 centimeter into 3, 2 cos 3 plus 1. So in that size only it will be there. It's like a miniature. So last but not least, I would like to include that why SG90 is for. Means there will be another model like stepper motor. Why it's named as SG90? So here 90 means it can accurately turn 90 degrees. So from 0, 90, 180. It can do sweep, but it can stop in correct accurate 22 degrees or 22.5. Like that, it can't stop. So it can stop like 90 degrees, 90, 90, 90. That 290s will be accurate. The rest of them, it will be sweep. So it's like some blabbering will do it. So thank you. I hope you understood my shop talk. Thanks.